Netflix serves 700 million hours of video every single day. That's not a typo, 700 million hours. Most people think Netflix is a streaming company. By the end of this video, you'll understand why that's wrong. Because behind a single press of play on Stranger Things lies one of the most sophisticated engineering systems ever built. A system so carefully designed that Netflix regularly tries to destroy it just to prove it survives. Today we're going to follow that single press of play, from your finger on the button all the way to the pixels on your screen. By the end, you'll know something most Netflix engineers didn't know on their first day. To understand why Netflix engineering is so remarkable, you first need to understand the scale of the problem they had to solve. Back in 2007, Netflix was a DVD rental company. You ordered a disc, it arrived in the mail, you watched it, you sent it back. Simple. Then they made a bet that changed everything. They decided to stream video over the internet, and almost immediately they hit a wall. In 2008, their database went down for 8 hours. DVDs couldn't ship. They realized that if they moved streaming onto that same fragile setup, one bad night could wipe out millions of users. They needed to rebuild from scratch, not patch the old system. Because streaming video is nothing like loading a web page. A single web page might be a few hundred kilobytes. One episode of Stranger Things in HD is several gigabytes. And Netflix needed to serve thousands of those at once, then millions. Think about what that actually means. At peak hours, Friday evenings, Sunday nights, Netflix handles over 15% of all internet traffic in the world. Not 15% of streaming traffic, 15% of the entire internet. No single data center could handle that. No single network could survive it. So Netflix had to rethink everything. The solution they built changed how the entire internet works. Here's the first thing that surprises most people. When you press play on Stranger Things, that video does not travel from Netflix's headquarters in Los Gatos, California, all the way to your device. That would be catastrophically slow. Instead, Netflix uses something called a Content Delivery Network, or CDN, and it's one of the most important ideas in all of modern internet infrastructure. Here's how it works. Netflix has made deals with internet service providers and data centers all over the world, in thousands of cities, on every continent. Inside those locations, Netflix has installed its own custom hardware. Servers it calls Open Connect appliances. These servers are preloaded with Netflix's most popular content. The top movies, the trending shows, the new releases, all stored locally, physically close to you. So when you press play in Mumbai, you're not pulling data from California. You're pulling it from a server that might be a few kilometers away, inside your own ISP's network. This is why Netflix loads so fast. The video was already near you before you even opened the app. But here's where it gets clever. Netflix doesn't store every single piece of content on every single server. That would be impossible. Netflix's library is enormous. Instead, they use smart algorithms to predict what content will be popular in which regions and pre-position it accordingly. Your city's server might have Stranger Things, the latest Bollywood hits, and whatever just went viral, because Netflix predicted you'd want them. Okay, so your video is coming from a nearby server, but there's still a problem. Your internet connection isn't constant, it fluctuates. Sometimes fast, sometimes slow, sometimes dropping for half a second when your neighbor starts downloading something massive. If Netflix just streamed at a fixed quality, you'd buffer constantly. Every dip in your connection would freeze the screen. So Netflix built something called adaptive bitrate streaming. And it's quietly one of the most elegant solutions in consumer technology. Here's how it works. Every piece of content on Netflix, every movie, every episode is encoded, not once, but dozens of times, at different quality levels. From low resolution 240p to all the way up to 4K HDR. In fact, Netflix encodes each title into over 120 different versions, different resolutions, different codecs, different bit rates. So the system always has exactly the right file for exactly your connection right now. When you press play, Netflix doesn't immediately send the highest quality version. Instead, it starts a continuous conversation with your device. Every few seconds, your Netflix app measures your download speed and reports back. The servers listen to that signal and dynamically switch which version they're sending you in real time, midstream, without you ever noticing. Your connection speeds up, the quality silently upgrades. Your connection drops, the quality steps down before you ever see a buffer. This is why you can start watching on a slow connection. Walk into a room with strong Wi-Fi, and the picture quality improves almost instantly without the video ever stopping. So far, we followed your video from a nearby server to your screen. But Netflix isn't just a video delivery system. It's also a login system, a billing system, a search system, a recommendation engine, a download manager, and hundreds of other things, all running at the same time. How do you build a system that does all of that reliably at Netflix's scale? In 2008, Netflix's entire service went down for 3 days. The cause was a single database bug. One bug, 3 days, millions of users. That moment forced Netflix to ask a question that changed software engineering forever. What if no single bug could ever take down the whole system again? The answer is microservices. A traditional application is built like a single giant machine. Everything connected to everything. One failure can bring down the whole system. Netflix broke that model completely. Instead of one giant application, Netflix runs over 1,000 independent microservices, each one responsible for a single job. One service handles login, another handles search, another handles billing, another handles video playback, another handles your watch list. Each service is completely independent. They communicate with each other, but they don't share code, they don't share databases, and crucially, one failing doesn't take down the others. So if Netflix recommendation service has a problem, you might see a slightly worse homepage, but you can still log in, still search, still press play. The core experience survives. This architecture is why Netflix can deploy hundreds of updates to their system every single day, because each team owns their service independently without coordinating a massive company-wide release. Now here's the part that genuinely surprises most engineers the first time they hear it. Netflix doesn't just build systems designed to survive failure, they actively, deliberately cause failures in their live environment to make sure those systems actually hold up. They have a tool called Chaos Monkey. Chaos Monkey is a program that runs inside Netflix's live infrastructure and randomly shuts down servers. Not in a test environment, in production, on real servers, while real users are watching. The thinking behind it is brilliant and slightly terrifying. If your system is going to fail eventually, and every system will, you want to find those weak points yourself during business hours when your engineers are awake and ready to fix things. Not at 3 in the morning on a Saturday when millions of users suddenly can't watch. Netflix calls this discipline chaos engineering. Over time, they extended it far beyond Chaos Monkey. They built tools that simulate entire regions of their cloud going offline. Tools that inject delays into the network. Tools that corrupt data midstream, all while Netflix keeps running. The result is a system that has been tested against almost every failure mode imaginable and learned to survive all of them. There's one more system worth understanding, one that shapes your Netflix experience more than any other. 80% of content watched on Netflix is discovered through its recommendation engine, not through search, not through browsing, but through the algorithm deciding what to show you. 4 out of every 5 things you watch on Netflix, the algorithm put there. So how does it work? Netflix tracks an enormous number of signals, not just what you watch, but when you pause, when you rewind, when you abandon a show after 8 minutes, what time of day you watch, what device you're on, and what users with similar taste are watching. They even track whether you finish the credits, because someone who sits through the end credits is statistically more likely to be a genuine fan, not just a casual viewer. All of those signals feed a machine learning model that is constantly re-ranking what to show you. Your Netflix homepage is different from everyone else's, personalized in real time, right down to which thumbnail image of a show Netflix shows you, because they've learned which images you're more likely to click. Netflix estimates this recommendation engine saves them over $1 billion a year in customer retention, because people who keep finding things to watch don't cancel. Let's retrace that journey one last time. You pressed play on Stranger Things. In the milliseconds that followed, your request was routed to the nearest Open Connect server, possibly just kilometers away. The video began streaming at a quality matched exactly to your connection speed, adjusting silently as your network shifted. Behind the scenes, over 1,000 independent services coordinated to handle your login, your billing, your playback. Each one independent, each one resilient, regularly stress tested by systems designed to break them. And the reason, Stranger Things was even on your screen in the first place, a recommendation engine that has been quietly learning your taste for years. Here's the truth about Netflix. It's not really a streaming company. It's an engineering company that happens to stream video. The infrastructure they built, the CDN, the adaptive bitrate system, the microservices architecture, the chaos engineering discipline. These ideas didn't just change Netflix, they changed how the entire internet is built. So the next time you press play and your show loads instantly, you'll know exactly what just happened.